Irodov problem number 1.71. A pulley fixed to the ceiling of an elevator car carries a thread whose ends are attached to the loads of masses m1 and m2. The car starts going up with an acceleration w0. Assuming the masses of the pulley and the thread as well as the friction to be negligible, find the acceleration of the load m1 relative to the elevator shaft and relative to the car, and the force exerted by the pulley on the ceiling of the car. This is a nice problem which will test your skills on how to apply pseudo forces. So let's start with the diagram first. So here we have a elevator car. Okay. And there is a pulley hanging from the ceiling, and there is a string going through the pulley. We have a mass m1 on this side and mass m2 on this side. The elevator car is itself accelerating with some acceleration w0. Now the question is to find m1's acceleration with respect to the elevator car and m1's acceleration with respect to the elevator shaft. Now what is the elevator shaft? The elevator shaft is in which the elevator is moving up. So it is fixed to the ground. So with respect to elevator shaft is same as asking with respect to ground. Okay. So there are two frames of reference. First frame of reference is in the elevator, as if someone is inside the elevator and watching m1 go up or down. And the other reference frame is on the elevator shaft. So as if someone standing on the ground and watching how m1 is going up or down. Okay. So for this problem, let's assume that m1's acceleration is upward. A is with respect to the elevator car. Okay. So let's say A is the acceleration of m1 with respect to elevator car. Okay. Now let's say A dashed is the acceleration of m1 with respect to elevator shaft or earth. Okay. So it's important to make the differentiation. It is with respect to what? Okay. Now let's take the frame of reference of the elevator car. Okay, this means we are looking at m1 and m2 in the frame of reference of elevator car. Now this frame of reference itself has an acceleration with respect to earth, and its acceleration is w0. So this frame of reference is a non-inertial frame. Now you would know that we cannot apply Newton's laws in a non-inertial frame directly. We'll have to introduce something called a pseudo force so that we can apply Newton's laws in a non-inertial frame. So with that knowledge, let's draw the free body diagram of m1 and m2. Okay. So if m1 is going up with acceleration a in this reference frame, m2 will go down with the same acceleration a in the same reference frame because it is a continuous string. Okay. So let us draw the free body diagram of m1. So m1 will have m1g acting downwards, tension in the string acting upwards, and m1 is moving up with acceleration a. But remember, we are dealing it in a non-inertial frame, so we'll have to include a pseudo force which is opposite to the direction of the acceleration of the non-inertial frame, and the force value will be m1 times w0 acting downward. Okay. Now similarly for m2, we can write m2g, same tension, it is accelerating with acceleration a downwards, but since we have w0 with which the non-inertial frame is accelerating up, so we'll have to introduce a pseudo force which is equal to m2w0. Okay. Now we can write the equations of motion. So tension minus m1g minus m1w0 is equal to mass m1 times acceleration a, and here we can write m2g plus m2w0 minus tension, so net force is equal to m2a. Let me just indicate this as pseudo force. Similarly, this is pseudo force. Okay. All right. So now our goal is to find A. The only unknown here is T. If I add these two equations, equation 1 and equation 2, T will get cancelled out. So we will get m2g plus m2w0 minus m1g minus m1w0 equals m1 plus m2a. Or we can write A equals, see here, if I take G common, m2 minus m1, w0 common, m2 minus m1. So we can write m2 minus m1 divided by m1 plus m2 times G plus w0. Okay. So that is the acceleration with respect to the elevator car. Great. And this acceleration, we took it in the upward direction. So if m2 minus m1 comes out to be negative, so if m1 is more than m2, then it will evaluate to negative, which means acceleration is in the downward direction. Okay. All right. Now let's find out A dashed. So A dashed is easy to find out because vectorally, so A dashed is acceleration of m1, let's say 1, with respect to ground or shaft. We can write that as acceleration of 1 with respect to elevator car plus acceleration of car with respect to ground. So this is the vectorial representation. Okay. So now both these quantities are known and all are in the same direction. So we can write A dashed is acceleration of 1 with respect to C. Acceleration of 1 with respect to the car is nothing but A, and acceleration of car with respect to ground is w0. Okay. So this plus w0. So how much is that? We can write m2 minus m1 g plus m2 w0 minus m1 w0. So I just expanded this, and in the denominator we have m1 plus m2, and we need to multiply this with w0. So plus m1 w0 plus m2 w0. So you can see m1 w0, m1 w0 we can cancel out, and these two are 2 m2 w0. So A dashed is m2 minus m1 g plus 2 m2 w0 divided by m1 plus m2. Okay. So we got this result. Now, so the last part of the question is, with what force the pulley is pulling on the elevator car, the ceiling, right? So if I look at the pulley here, and it is pulling on the ceiling, and there are two tensions T, T. So this has to be 2T. So the force with which the pulley pulls the ceiling is equal to 2T. So we have to effectively find the value of T. Okay. So if I know A, I can just put it here in equation 1 and find the value of T. So let's do that. T equals m1a plus m1g plus m1w0. Now m1a, just expand this, okay? So m1 m2g plus m1 m2 w0 minus m1 squared g minus m1 squared w0, and then we multiply m1 plus m2 with this, so that becomes m1 square g plus m1 m2 g plus m1 squared w0 plus m1 m2 w0, and all of this divided by m1 plus m2. Let's just move this to here. Now we can see m1 squared g, m1 squared g, m1 squared w0, m1 squared w0. So now we have 2 m1 m2 w, 2 m1 m2 g, 2 m1 m2 w0. Okay. So 2 m1 m2 g plus w0 by m1 plus m2. Okay, so this is the value of tension. So the force is 2T, so that will be 4 m1 m2 by m1 plus m2 times g plus w0. So that's the force exerted by the pulley on the ceiling of the elevator. Okay. So that's our solution.